Hello everybody, this is Fabricio Rodriguez from the University of Campinas, UNICAMP, and I'm going to present our work P7, P4 Programmable Patch Panel, an instant 100G emulated network testbed in a Pixelbox. Our agenda for our presentation is going to be a P7 overview, the link characteristics, of the generated files, the demo, the topology definition and generation, the challenges, and the future of P7. Options to validate the network topology, including the link metrics, are traditionally based on virtual environments. For instance, Mininet, limited experiments with transmission speeds over 10 gigabits per second. With the programmability that P4 brings to the network and the capabilities of new generation hardware supporting the portable switch architecture and the Tofino native architecture, P4 architectures, it is possible to define emulation characteristics of the links and represent the network topology with high fidelity and computation power using a simple physical P4 switch, for example, a Tofino. This demo features P7, a network emulator tool to test and validate network topologies and their characteristics in a 100G pizza box. The emulation of network link characteristics includes simple metrics such as connectivity, latency, bandwidth, and advanced metrics such as packet loss, jitter, reordering. These metrics are implemented in a P4TNA environment to create a realistic network topology emulation, turning experiments in SDN, testbeds, reach, and embracing. This is the list of the P7 link characteristics that are implemented. The link connectivity is implemented using internal recirculations and internal tags. The latency, it uses an internal timer, the traffic manager features, and the pipeline's recirculations. Jitter, use a hash to determine the recirculation times and how the latency is going to change. The packet loss, use a random function to determine the probability to discard the packets. Reordering, use the traffic manager features, and bandwidth, use a rate limit TNA traffic manager feature and the port configuration and mapping characteristics. This is an example of a topology that can be emulated using P7. In this topology, each link has a specific characteristic, for instance, bandwidth, latency, packet loss. Physical servers are connected to the Tofino that represent the hosts that are part of the network. The representation of the topology in P7 can be seen in this figure. Here we can see where the P4 code will be focused. That are the link characteristics, since the link characteristics are the central part of the P4, and each link needs to be treated as an individual entity inside the P4 code with different configurations. Using internal recirculations and internal tags, it is possible to create the logic of all the different links as long as the packet paths. This is an overview of how the user defines a topology within P7 and then how the generated files are mapped to the different parts of our environment. We use a stratum to facilitate the ports and tables configuration. So what the user is going to do, the user is going to set the topology in a main file. Using this main file, three files are going to be generated. The first is the P4 program. Here we are going to have the logic of the topology that the user defined in the main file. We are going to have the chassis configuration that is going to be used by Stratum to set the different interfaces and how the hosts that are physically connected are going to be mapped. Finally, we have the tables information that is going to be sent using P4 runtime to set all the table information inside the P4. It's important to mention that the user needs to define the port distribution of its own Tofino, since the port's number or the port ID can change from hardware to hardware. Now I'm going to show a simple demo where we are going to define different topologies, different link characteristics, and then we are going to validate if the values that we set are working as expected. First, let's talk about the link characteristics. So the physical topology that we are going to have are, for instance, two physical hosts connected to our P4 hardware. In this example, it's going to be a Tofino hardware. This physical topology is going to be emulated as a host, link host topology when we don't define any switch or device in the middle. So this is going to be a direct link connection. So we can emulate characteristics of a single link. We can add devices in the middle. Then we can have an emulated topology as a host, link, a switch, a link, and a different host. And we can emulate complex topologies where we are going to have more than one devices in the middle, and then we are going to have different links between each of these devices. It's important to mention that inside P7 we have a predefined VLAN that is the one that is going to pass through all the internal processing that is going to emulate the different link characteristics along the different links and paths inside the topology. We can have additional VLANs working at the same time with no P7 processing. So in this way, we can compare a direct link between H1 and H2 or two hosts and the processing inside the emulated topology and the characteristics. Now I'm going to show you how to set the different topologies inside the P7. So basically this is the main part of the our P7 script. Here we're going to define all the host, switch, and all the parts that we will need inside the topology. We can add different hosts, setting a name for each host, the port number and port ID of the host, and the link characteristics as the port speed and all the additional port configurations. We also are going to indicate here the VLAN that is going to work with P7 and these specific links. When we have a direct link with no any device in the middle, we can define the link between H1 and H2, our two hosts, and then we can define the different characteristics of the link, like the bandwidth of the link, the packet loss of the link, and the latency of the link. If we have different devices in the middle of our topology, we are going to define these devices as suites, and then when we define the different links with the corresponding characteristics, we are going to create our topology. So now we are going to define two links, one from H1 to switch 1 and from switch 1 to H2. Starting with the demo, we have here 5 terminals. One where we are going to build and run the P4 runtime, two terminals related with the T-Rex, one where we're going to have the console and the other one with the output of the T-Rex measurements, one terminal where we are going to have the Stratum running, and finally one terminal where we are going to see the P7 configuration and we will be changing the topology. Okay, so first let's edit the the main P7 file where we are going to define our topology. So as I mentioned before, here we are going to have two hosts. Basically, we define the name of the host, the port that are related with that host, and all the port information that we will need to set for that specific hosts. Also, we're going to add a link between that two hosts, and also we will define the characteristics of the link. For this example, we will be limiting the bandwidth to validate if the bandwidth is being set accordingly. In this example, we also are adding two ports with a different VLAN just to send some direct traffic, but we will not use for this demo. Let's just run the main file. Here we have the output of of the main script, what we are going to have the description of the host that we added, the links that we added, uh, all together with the configuration of the link, the additional villains that we will have, and the topology that we will be presenting now. So in this example, we are going to have a direct link between host 1 and host 2, but with the characteristics that we will set in the in P7. Now we send the files to the correct places. We will move to the built-in terminal. So here, what we're going to do is to build the our P4 code. So now it is building. We can also start running the Stratum. One important part is to define where the chassis configuration is going to be. So we will set with the files that are generated by the P7 and the chassis configuration that is generated by our script. So we'll set that chassis config flag, and then we can run the Stratum. Okay, here we have our code compiled, so we can now uh, send the code to the Stratum and to the Tofino. So we will run our script that it will start the P4 runtime communication. Now it's being sent the P4 code. The tables are also being set, and now we have everything uh, ready to start testing the network. Okay, here we have the a small topology. So basically, we define one IP for each of the ports of this T-Rex server, and we will just validate the RP tables just to confirm that everything is working. And now we can start sending some traffic. So let's send some traffic from port 0 to port 1. So let's send the traffic. So we will be sending 1 gigabit per second from port 0 to port 1, and we will see the results. As we can see here, the transmission rate is 1 gigabit per second, that is what we set, and we are receiving just 100 megabits per second. Why? Because in our P7 script we defined the link maximum bandwidth to 100 megabits per second. So here we can confirm that the bandwidth limitations that we are setting in this link are working. Now let's change again our configuration file. Let's set to 1 gigabit, the maximum bandwidth. Let's set now some packet loss. So for the instance in this example, let's set 10% of packet loss. So now run again our script. We set the files in the correct places. File again our P4 code, and for these examples in the chassis has changed, we will need to run again the Stratum. So let's run again our Stratum. It's just starting in the Stratum to read the new chassis file. Just let's wait to be Stratum running, and then we can send again our our P7 file. Here, well, we will need to run our T-Rex again since there was an issue with it. So let's run again. Okay, we compile it again, so now we can send the code. Just let's quickly set the links again. So we will need to set the VLAN since we are using the P7 VLAN. We set the port configurations. So now set to one and other port. Now let's run up our ARP that it's running. So perfect. And then, okay, let's test again to see if the packet loss is working. Send again 1 gigabit per second in port 0. Now it should not be limited to 100 megabits per second. So let's see the behavior now. Okay, so now what we have changed. So now what we set is 10% of packet loss, and as we can see, the transmission rate is 1 gigabit per second, and the what we are receiving in the other side is around 900 megabits per second. So we are having around 10% of packet loss in the link. So this is how we can confirm that the packet loss is working. Now let's set some latency value just to verify one metric per time. I will set the packet loss to 0 again, and now we will define a 10 millisecond bandwidth to run again our P7 script, set the files, and we will need to compile again our P4 code. So in this example, since we haven't changed any bandwidth at all, we don't need to start again the stratum. So we can just compile the P4 code and send it again using the P4 runtime. Can send the P4 code again. Can stop here the traffic transmission. Okay, so our P4, new P4 file is ready. Just confirm the ARP tables are okay. Okay. And now let's test some delays. So for this, what we can do is to send a ping between these two IPs. It's like the simple way that we have to test latency is working. So let's see ping that from port 0 to destination 1.1.2.1 send 10 packets. So, yep, so we can see here that the latency is 20 milliseconds. Why? Because the ping is showing the RTD time. So we have 10 milliseconds in the link, and we will need to send and receive back the reply for the ping. We will be seeing the double of the latency that we have set. So we can confirm here that the latency values are working. We can set a high number of ping messages to send just to see the ping, the latency values here. So with this, we basically have seen the main metrics of the P7. What are the packet loss, the latency, the bandwidth, and now let's add a switch in the middle since we have just tested a direct link connection. So these lines, let's add the switch as we mentioned before. So we are adding now the switch. We are adding the two links because now we have one link from H1 to the switch and from H2 to the next to the switch from to H2 that is the next host. Let's define 10 milliseconds of latency just to test. Run again the remaining script, and now we can see that the topology have changed. So now we have two hosts and one switch in the middle, and we can still increase the number of the switch accordingly to the topology that we want to emulate. We set the files in the correct places. We need to run again, compile again our P4 code. Let's just cancel this ping and let's just wait for P4 being compiled. Okay, now we can set it through the P4 runtime, the new P4 code. Okay, so it's ready. Let's just test again with 10 pings. It's okay. Now we have 40 milliseconds. Why? Because we exceeded our image of the topology. We'll see that when we send a ping from H1 to H2, the first message will pass through the first link that it has 10 seconds latency, then it passes through the second link that it's plus 10 milliseconds bandwidth, latency, sorry, and then the message it needs to came back to H1 since the time that it's showing here is the RTT, so we have plus 10 milliseconds and plus 10 milliseconds, so in total is 40 milliseconds latency, so we can confirm here that latency is being set correctly. Now let's talk about the future of P7. What we are expected is to address open challenges, like the fidelity of the emulation of the metrics, like the bandwidth, the jitter, the packet loss, the topology size, the buffer consumption. We will add new features, like the packet generation for background congestion traffic using the internal Tofino capabilities to generate traffic, and in-band network telemetry capabilities to be able to see how the buffers, how the queues are internally in each of the switch along the topology. Dynamic link behaviors. We can add different packet loss patterns to have realistic characteristics of the metrics, trace-based link characteristics. Another important part of the P7 is the open source code and the community that we want to start. We also are thinking to embed into disaggregated network testbed initiatives to have more characteristics inside the P7 to give more power to the topology emulation and the characteristics that can be done inside the P7. The P7 repository is going to public available soon, so please check this link in the next weeks. It's important to mention some related and referent works as Mininet, Turbonet, CrystalNet, BNV. There are works that started with this idea of the emulated topologies and also are the base of our work. Thank you. If you have any doubt or want to contact me, please feel free to send me an email. Thank you.